So in this video, we're going to go over we're going to go over what's called the unit circle. Now, if you've seen the unit circle before, this is going to be a review, but it's a review worth looking at because it's really helpful when you're trying to figure out sine, cosine of different angles. So before we jump into the unit circle, let's review quickly our special triangles. So this is our 30, 60, 90. Remember we have the side length square root of 3 over 2, 1/2, 1. And if we have 45, 45, 90 triangle, we have, this is 1, this is square root of 2 over 2, this is square root of 2 over 2 as well. Okay, so how is this useful? Well, it can be really hard to memorize what exactly the values of sine and cosine of these are. But what we can do is we can use what's called the unit circle. So here we have a circle of radius 1. It's the unit circle. So our radius is 1. So what we can do is we can draw all of these triangles on this circle because no matter where you draw your triangle, the hypotenuse will be 1. So let's start with this triangle. So let's take a point, and let's say that it is at square root of 3 over 2, 1/10. Well, if we were to draw a triangle to that point, we would know that this is a 30-degree angle. So what we can say is, since the hypotenuse is 1, if we want to look at the sine of 30 degrees, that's just the height divided by the hypotenuse. Well, the height is this, and the hypotenuse is 1, so the sine is really just that. And the cosine is the length, or this value, the x value, divided by the hypotenuse, which you get is 1. We just get that. So what we see is, at every point on this circle, the xy value corresponds to the cosine of the angle. So if we have some angle, we'll call it theta. So Greek letter theta is often used for angle. So just given any angle, the x and y correspond to cosine and sine. So let's say we had this point, square root of 2 over 2, square root of 2 over 2. Well, if we try to find the angle that is made connecting the origin to that point, we'll find that it's 45 degrees. So we can say the cosine of 45 degrees is the x value here, so square root of 2 over 2, and the sine value is the y value, square root of 2 over 2. And the same thing works for all of these points. So here we have the point 1/2, square root of 3 over 2, which is the angle that makes that point is 60 degrees. So we know that the cosine of 60 is 1/2, and the sine of 60 is square root of 3 over 2. So all we really need to know about these angles is these three numbers. We need to know 1/2, square root of 3 over 2, and square root of 2 over 2. If you know these, you know basically all of the special angles you're going to have to memorize. All you have to know is the angle farther over than it is up, or is it farther up than it is over? If it's farther over than it is up, like 30 degrees, then the cosine is going to be square root of 3 over 2, because square root of 3 over 2 is greater than 1/2. So if it's higher than it is wide, like 60 degrees, then the height is going to be square root of 3 over 2. So these are the three important numbers that you need to know. Well, we can also look at this point. So if we look at 90 degrees, we see that 0. The cosine, okay. So the cosine is 0 because the x value is 0. The sine is 1 because the y value is 1. And that's all there is to it. If we look over here, the cosine of 0 is 1, and the sine of 0 is 0, just like we found before. Even if we go all the way over here to 180 degrees, we have the cosine is -1, just like we found, and the sine is 0. So this works for any angle. We can keep on extending it. If we go here, 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 it doesn't matter. We can still just use the coordinate points. Well, this point is going to be -1/2 square root of 3 over 2. So we know the cosine of this angle is -1/2 because that's its x value. This is going to be negative square root of 2 over 2, square root of 2 over 2. So we can find the sine and cosine there. Same thing here, negative square root of 3 over 2, 1/2. Okay, well, we can extend this. So if you notice here, both values are positive. Here, cosine is negative. If we were to go down here, we would see that we get both values being negative. And over here, we have the cosine is positive, and the sine is negative. So, it's easy to keep track of which values are going to be positive and negative based off of which quadrant you're in. So if you have your angle in this quadrant, sine and cosine, and therefore tangent, will all be positive. If you're over here, you're going to have the positive ones are going to be simply just sine, because cosine is negative, and since tangent is sine over cosine, it'll also be negative. If you look over here, sine and cosine are negative, but that means tangent is going to be positive. And over here, we just have cosine being positive because sine is negative. So if you can remember this, you can remember which ones are positive. So people say Axe, I went to Hicks Creek, so we say Allstate Hicks Creek, but you can have your own little mnemonic. So this is how you can remember positive and negative signs. Now, one more thing about this. We really don't like to use degrees all that much. Degrees are just, they're not used in science as much as what are called radians. So let's go over what radians are. Okay. So, if we look at our unit circle, and this is radius 1. So this is a circle of r equals 1. What is the circumference of this circle? Well, the circumference is 2 pi r. So, in our case, the circumference is 2 pi. So instead of saying 360 degrees is one trip around the circle, we say 2 pi is a trip around the circle. So if we start at 0 and keep adding our angles as we go around, instead of being 360, we say this is now 2 pi. Okay? Instead of saying 180 here, we say this is pi because it's halfway around the circle. Same thing here. This is no longer 90. This is pi over 2. And here is 3 pi over 2. And so we can keep breaking this down. So 45 degrees right here will be pi over 4 because it's half of pi over 2. And if we look at 30 and 60, you can figure out pretty quickly that it'll be pi over 6 and pi over 3. So you have pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which is the same thing as 2 pi over 3. Then we have, well, pi over 4, pi over 2, 3 pi over 4. And then you add another pi over 3 to get here. So 5 pi over 6, and then you're up to pi. So what I'm doing here is I'm labeling these based off of increments of pi over 6 and pi over 4. And that's the most common way to do this. So if we keep going, we'll get 7 pi over 6, because this is 6 pi over 6. And then this will be 3, 4, 5 pi over 4. We'll get 8 pi over 6, that reduces to 4 pi over 3. And you just keep moving this pattern along. So what we're looking at here is the same exact circle, but labeled in what are called radians. And notice I don't have to put a little r or a capital R here for radians. You just simply label it as pi over 6. So what we can say is, instead of writing sine of 30, we can write sine pi over 6 is equal to 1/2. Or we could say cosine of pi over 4 is square root of 2 over 2. And so if you really want to convert back and forth, because you might not be used to it yet, the conversion is there are 360 degrees in every 2 pi. Another way to write that is there's 180 degrees for every pi. Okay. So one last thing I want to talk about is the idea of a negative angle. So when we measure angles, we usually measure from the x-axis going counterclockwise. However, it's sometimes convenient to look at a negative angle. So a negative angle is just starting from the x-axis, and instead of measuring this way, we simply measure this way. So this would be negative pi over 4. Similarly, this would be negative pi over 2. Well, you might say, well, negative pi over 2 and, for instance, 3 pi over 2 are the same angle. Well, to differentiate between the two, we still call this negative pi over 2 and this 3 pi over 2. But we call them coterminal angles. They terminate on the same spot, on the same line. So while it's true that sine of 3 pi over 2 equals sine of negative pi over 2, we still consider them different angles. Just like we can say pi over 2 is a different angle than pi over 2 plus 2 pi. So just going around the circle one more time. Yes, they'll have the same sine, cosine, tangent, secant, cosecant, blah, blah, blah. But we still call them different angles. So that's the idea of a coterminal angle and negative angles. Okay, so now you know how to use radians. This is how you label the unit circle. So you really need to have in your head this picture of the pi over 6 and pi over 4s labeled out, because you really needed to memorize those. And your professors might expect you, by the time you get to Calculus 1, or especially Calculus 2, to have known the sine, cosine, and tangent of pi over 6 and pi over 4 and all of their multiples. So this is a really useful tool to remember the sine and cosine just right off the bat.